In these two examples, we need to find the equation of an ellipse given major vertices and eccentricity and the minor vertices and eccentricity. So in the first case, we're given major vertices plus minus 4 comma 0. So what we can do, we can immediately plot those. So plus minus 4, so that means it will be on the x-axis based on the coordinates here for the major vertices. So let's plot the first one. It's 1, 2, 3, 4 comma 0. And minus 4 comma 0, right? So the other way around, the same number of ticks. 1, 2, 3, 4. Okay, so these are the major vertices. Okay, so we know that the center will lie right between them, right? So the center must be the origin. And to confirm that result, we can solve for A. And we know A is responsible for the amount that you go from the center in both directions. Okay, so to confirm that A is equal to 4, we can just subtract one x value from the other. So basically, we're going to take the positive 4 and then subtract the negative 4, the second x coordinate here for the second vertex here, major vertex, and then simply divide it by 2, right? Because we're looking for the average, right? We're looking for the midpoint. So that means we're going to have 4 minus negative 4 is 4 plus 4, which is 8, divided by 2 is equal to 4. So we confirm that the A value is 4. Now, we need to find the equation of an ellipse. Okay, an equation of an ellipse will have A and B, A squared and B squared precisely, to be more exact. And we already found the A. Now we need to find the B squared. We know the C. And the way to know the C is to use the eccentricity. We know the eccentricity is equal to C divided by A. So we know that C divided by, and let me put that in the blue, C divided by the A value, and the A value is 4, like we just found, is equal to 1 over 4, right? Because that's the given eccentricity, and that stands for the left side that we can substitute, right? So in this case, I'm just going to write it on the right side, 1/4. So as you can see, you can solve it two ways. You can notice that the same denominator means that the numerators will have to be equal. So C is equal to 1. C is equal to 1. Or you can just cross multiply. 4C is equal to 4, and then just solve for C by dividing both sides by 4, and you will get C is equal to 1, right? So two ways of solving it. So we now know the A and the C. So now we can solve for the B squared because we know the A squared and the C squared, right? So we can do that. We can do 4 squared, substituting for this equation, is equal to B squared plus 1 squared, right? Because that's the C value we found. So B is going to be the square root of the 4 squared, which is 16, minus the 1 squared, which is 1, right? If you subtract 1 from both sides, 1 squared is 1, right? So I can just subtract it on both sides. B squared will be by itself. Then you take the square root, you will get this, the square root of the difference of 4 squared and then 1 squared, right? Which is 16 minus 1. So that is equal to radical 15. Okay? So we found out that the B value is radical 15. So the equation that we need will involve A and B. Okay? And its major vertex is on the x-axis. Okay? Which means that basically your A will lie underneath the x when it comes to finding the equation, right? So in this case, x minus h. So we know that the h and k, the center coordinates, as we found out, were 0, 0. Right? So x minus h, we don't need to write minus h and squared because h and k are both 0. So we can just write x squared plus y squared, the same thing, because the y coordinate of the center is also 0. So we don't need to subtract the h, because the k, because the k is not going to matter. It's 0. So is equal to 1. And what goes underneath these are the A values and B values. The A value stands on the major axis, right? It's 4, and it's on the it stands on the x-axis, right? The major axis is on the x-axis. So that's why A should be placed here. A squared should be placed here rather than here, because the major axis is parallel to or on the x-axis in this case. So a squared must be here. So a squared is 16, right? Because 4 squared is 16. And then y squared will have the b, right? Because we already placed the a squared, so the y squared will have the b squared underneath. So b squared was 15, right? We don't really need to take the square root because we need to square it back again, right? So 15, right? 15 is equal to 1. So there goes your equation. So once again, to find that equation, you need to find your respective centers. In this case, it didn't change. We did not need to write minus h and minus k because both h and k were 0. So that would not affect it. So that was the simple part. But the harder part was that we needed to figure out where the a squared goes, underneath the x squared or underneath the y squared. In this case, since the major axis is on the x-axis or parallel to the x-axis, whichever it's going to be, you will put those a squared underneath the x squared or whatever deals with the x. In this case, b squared goes underneath the y squared. All right, so this is the equation of this ellipse. And if you want to put the radical 15 is just a little below radical 16. Radical 16 is 4, right? So we know that radical 15 should be somewhere here, right? So that would be in both directions from the center, 1, 2, 3, just a little bit above the 4 in this case, and a little above the negative 4 in this case, and below the 4 in this case, right? So it will look something like this. If you connect it, it may look like a circle, but keep in mind that it's not a circle because the distance here from the center is 4, whereas the distance here, the minor radiuses of this ellipse, is not 4, it's radical 15. Radical 15 is smaller than 4, right? So it's not a circle. All right, so in the second case, it's going to be a little bit harder. And notice, before I go on, we did not need to use the foci, right? Because the foci are not responsible for finding the equation of the ellipse directly, because foci are not basically components of this equation, right? But the eccentricity was used, for sure. The eccentricity was used. All right, so in the second case, we're given minor vertices -3, 4 and 1, 4. So let's plot them. So -3, 4 and 1, 4. So -3, so 3 to the left, 1, 2, 3, and then 4 up, 1, 2, 3, 4. That's here. And also 1, 4. So 1 right and 4 up. And the midpoint should be the center should be right in the middle, right, between these two. So the center, in the first case, it was the origin, because that was the midpoint. In this case, it's going to be right here, the midpoint of these two. And keep in mind that these are minor vertices. It says minor vertices, right? So this value, the distance here, is not going to be the a, it's going to be b this time, right? Because it's the minor vertices we're talking about, the distance from the center to the minor vertices. The b is responsible for that, not the a. So the b value should be 2. Let's confirm that. So the b value is 2. To confirm that, you just subtract, like we did in the previous example. You're going to subtract the x values, one x value from the other, right? So we're going to do 1 minus -3 divided by 2, right? 1 is the first x value, minus -3 is the second x value of this minor vertex, and divided by 2 to find the average or the midpoint between them, right? So it's going to be 1 plus 3 divided by 2, which is equal to 4 divided by 2, which is 2. So we confirm that the b value is indeed 2, the distance from the center to the minor vertex. So now we need to do more work. We know we can use the eccentricity now. We know that the eccentricity 4/5, and let's substitute what we know. C divided by A. Do we know the C? We don't know the C. So what I'm going to do first, I'm going to do C divided by A first. And we don't know the A. We don't know the A either. So I'm going to do C divided by A. And then what I'm going to do now, I'm going to write C in terms of A. So if you cross multiply, you're going to get 4A is equal to 5C. right? So what I want to do, I want to write C in terms of A using this. So C, as a result, is equal to 4/5 A. 4/5 times A. And once again, to do that, you just cross multiply. You get 4A is equal to 5C, and then just solve for C. And C is equal to 4/5 A. Right? You would basically divide both sides by 5. When you get 4A is equal to 5C, that equation, divide both sides by 5, you get this equation. C is equal to 4/5 A. And why do I need it? I need it because I can use this equation and this substitution, and then we will only have A visible, and we won't have a B because we already solved for it, right? B is equal to 2, right? So let's use that equation. So A squared is equal to B squared. B is what? B is 2, right? So 2 squared is 4. Plus, we need to square the C, right? We already have the C in terms of A, so we have to square the right side, right? To substitute for the C squared. So squaring this will give us 16 over 25 A squared, right? Squaring all of these three components, 5, 4, and A, gives us 16 over 25 A squared. A squared. So you see what I did? We now have only A squared in this equation, so we can solve for it. That's easy, right? So now what we do is subtract 16 over 25 A squared. So we can have the A squared on one side of the equation only as a result, and what we're going to have is, so let's see, 25 over 25 is the coefficient that we can express as a 1. So 25 minus 16 over 25 A squared is equal to 4, right? That's what we have as a result. So what that gives us is, let's see, that gives us 25 minus 16 is 9, right? So 9 over 25 A squared. So 9 over 25 A squared is equal to 4, which leads us to multiplying both sides by 25 over 9. Let's makes this coefficient 1, right? So what I'm going to do, I'm going to move this guy a little ahead. So we want to multiply both sides by 9 over 25, 25 over 9, that is, 25 over 9. You see, it eliminates the 25 and the 9. It has coefficient 1 as a result. So 25 divided by 9. So as a result, what we have is A squared is equal to, let's see, 25 times 4 is 100. So 100 over 9. So 100 over 9, so the A value as a result is the square root of that. And A should be positive, right? So the square root of that is 10 over 3. 10 over 3. So we found the A value. So as a result, the equation that we're looking for, now where's the center going to be? The center is going to be the midpoint. The midpoint of these two, okay? And if you want to do algebra, if you don't want to visualize, the midpoint should be -1, 4, right, by the graphical analysis. But if you want to confirm that, you're going to take the midpoint of these two for the x value, so -3 plus 1, this coordinate, divided by 2 to find the midpoint, right? And we know that the y value should be the same for the center, so it's 4. So that's going to be what? So the center is going to be -1 plus -3 plus 1 is -2. -2 over 2 is -1. So you confirm that the center is indeed -1, 4, just like you visualized it. So the equation that we need is what? X minus h, right? The h is what? We said that the center is h comma k. In this case, h is here. This is h, and this is k. Right? So this is hk. So x minus h means minus -1. Minus -1 is the same thing as saying x plus 1, and then squaring it, of course. Now, do we put the a squared or the b squared? Since we're talking about minor vertices, we're talking about minor axis, right? Minor vertices lie on the minor axis. Minor axis is parallel to the x-axis. Unlike in the first case, minor axis was parallel to the y-axis because the major axis was parallel to the x-axis. Here, the minor axis is parallel to the x-axis. So that means in this case, we're talking about the A coming up and down because the major axis will be parallel to the y-axis this time. So the A value cannot be written underneath this, underneath the x's. It's going to be the B squared instead, not the A squared. The B is 2, right? So the B squared is 4. So we put a 4 here. Plus, let's see, y minus k. What is k? K is 4. Y minus 4 squared. And then what do we put here? I might be running out of the room, so try to move this a little bit like here, so we can have more room. And why do I need room? Because our a squared will be huge, right? We know it's 10 over 3, so a squared is 100 over 9. So I'm going to put 100 over 9 here, and we don't have to square that, right? Well, I'll just put it under parentheses. 100 over 9 is equal to 1. So there goes your equation for this ellipse. You've successfully derived it using the known concepts of the A and B, orientation, position, etc. Right? So we know the A is 10 divided by 3. 10 divided by 3 is just a little bit greater than 3. Right? So we know that the major axis should have major vertices like this, a little bit over 3 in each direction. Okay, so somewhere like that. So as you can see, this looks more like an ellipse than this one because there's more difference between the minor radius and the major radius. You see, major radius is way bigger here than in the first case. In the first case, they were nearly identical. That's why it looks like a circle. In this case, it looks more like an ellipse because the minor radius is only 2 and the major radius is greater than 3, right? It's 10 over 3. Right, so we can connect that just for the sake of graph. So it looks more like an ellipse this time. And it has its standard orientation. All right. So I hope this was useful. Thanks so much for watching. See you in the next video.